Sorry. Yeah. So let's get started. Previously, we were seeing how classes are created and different methods and attributes within class. And then we went. Now let's see how fast NumPy is operations perform normal operations. This part is called vectorization. So all the elements that we store using NumPy are vectorized in a way. So, yeah. So we saw all the elements would be in a sequence. We create two arrays A and B. Each array contains random numbers between 0 and 1. 1 billion random numbers between 0 and 1. Then we create a dot product C between A comma. This percent time will tell us the time it took to run the specific cell. So here it took roughly 5 milliseconds. Let's do the same thing manually. We create a variable called sum. Its initial 0. Then we go through each and every element in these two vectors with the iterator. For I in range length of x will give numbers with 0 and 10. 1. So using that number, we are indexing through the elements in the list A and list B. So the first index will go A of 0, B of 0. This will give us a product. This product will be stored in this product. And then we'll add this to the initial edge to sum. So as the loop carries on, the value of the sum keeps increasing. So then we print out the final answer. So this is the same as this, except the end of the precision. So this roughly took 600 milliseconds, and this is say 5 milliseconds. So you can say roughly 100 times faster. The NumPy for NumPy dot product or NumPy backend is quite faster than. Now let's see how to create graphs. So here we know how to store data. Let's plot the data using Matplotlib. This is the implementation of MATLAB's plotting library in Python. So we'll just will from Matplotlib .pyplot will import pyplot as PLT. This is where all the plotting functionalities and this is a general thing saying that print everything that comes out of MATLAB in a inline. You just have to run this once just to display all of if you are not using the Jupyter Notebook, if you are trying to directly run the Python code, this won't be required. This is just to whenever you see percent or 2%, that is a command for the nodes, not the Python app. So now let's create a array. So x goes from 0 to 3 pi. So just by saying a range will give numbers from 0 to any end with the steps that we specify. So you need to slowly understand different methods available in Matplotlib and in Pandas. Pandas we'll see in the next class. So Pandas is a basic. It's a it's similar to Excel. So we have Excel or Google Sheets, right? In Python, the same thing we'll use as Pandas. It's a library created to deal with the Excel kind of tabular data. So here we are saying let's you create a array X that goes from 0 to 3 pi. 3 np dot pi is an attribute within np that gives us the value of pi with steps 0.1. See, what is X? See, 0 to 3 pi is 9.4. So with step 0.1, it is going to 9.5. And then we are creating the variable that stores the sign value corresponding to the these x's. So now we have the values for x comma y. So we have x is the x-axis and y is the value of the function at that point. So we have some list x and some list y. You can plot this just by picking plt.plot, giving the values inside here. So there are different kind of plots available, like scatter plot, line plot, and different plots. Depending on the requirement, you can go through the available plots and plots. Let's see more complex. We want to draw two different things on the same graph. We just put the same value and just directly plot. We are creating the plot. PLT will contain this plot. So every time we add something PLT.plot, it will be plotted on the same graph. So similar to that we do like indexing and things on our graph sheet. We can put our labels, title, legend, etc. And if you are to put towards like more number of plots, you can say that this PLT contains a subplot. So just by saying PLT dot subplot and giving what are the total number of plots and the location of each plot. So we are saying there are two plots here. This is the first comma first. So here is so this is the 1,1. This will be the 1,2. So here you can see. So y of sign we stored in y of sign. Cause is stored in y of trying to print out these two values and having the title, legend, etc. kind of thing. So any doubts till now? Okay, now let's we have gone through different things like NumPy and MatPlotlib and basic Python. We'll using all the things we learned till now, write a function to calculate the value of pi. So the value of pi is general. The value of pi somehow related circles, right? So the circumference of the circle will be 2 pi r, and the value, the area inside the circle pi r square. Well, let's say we have a circle of radius 1. And uh, this is the value of the circle that we have, and we need to find the value of pi from this. So yeah, now let's see. Previously we had set a common. Let's say plt dot scatter a so yeah, so A is a excuse. So A goes from 0 to 1 and some 1 0 to 1 and B goes from 0 to 1. So we have a square. So all these points are inside. So 0 comma 0 will be 0 comma 0 will be somewhere some other point. If let's say we have we create a tuple containing one value from a n and one value b n. So this will create a coordinate in xy plane that we can plot. So since a goes from 0 to 1, b also goes from 0 to 1. So all the points, say one point might be 0 comma 0 when both are zeros. 1 point can be 1 comma 1 when both the random numbers we got are 1 comma 1. That might be here. So one more thing is like 0 comma 1. And 1 comma 1 will be here. Some random point 0.75 comma 0.75 that will here. So by plotting all the points, you'll get the like all the plots will be like on this in this area. Right? So area of this part will be one since we are plotting side is one side forms a square. See, this is forming a square from 0 to 1. So the area of this is 1. Now we need to find all the points that are inside the circle. So area of this quadrant will be pi r square by 4, right? So these points are like all inside the circle. So pi, since r is 1, we have the area inside this is pi by 4. So now we need to from all these points, we need to find what are the number of points that are inside the circle. So the points inside the circle will have this thing called the distance from origin will be less than 0. Sorry, less than 1, less than or equal to 1, since we are using a circle. For all the points, distance from origin will be less than. So let's see. Let's create a variable called in. So in is a like a specific word that we use in Python. So we'll say so inside equal to 0. Now we need to create a function that will give us the distance from origin. We know like distance between 2 points is x2 minus x1 whole square plus y2 minus y square whole under root. Right? So since we are getting from origin, it would be x1 comma y1 0. So distance is like root of x2 square plus y2 square. So given 2 points, so it will return a distance. Let's create a function. Create a function. We put f space dist. We are giving some name. And it will take 2 values, right? X, comma, y. What will it do? Creates it will find out the distance. X square. So x square plus y square 4 under root, right? To get under root, we can do 0 power 0.5 and then return d. To let's say some example equal to distance from origin. Let's say 1 comma 1, and then let's print out this dx. So from 1 comma 1 will somewhere here, right? So the distance from here to here is 1.4. Let's say let's get from 0 comma 1. It will be 1, right? Yeah, see, this one. Oh, now let's use this function. For I in range length of A or B, both are of same length. This will give us the index. We need to find the distance. So some d will be distance from origin is our function, and will give the points from the A of I, comma B of I. This will give us the distance. Now, if d greater than d less than or equal to 0, what will we do? We'll say so here we put this. Will accumulate all the number of the points inside in this variable. So if distance is less than or equal to 1, sorry, so distance should be less than 1, right? This inside the circle. So distance, if distance is less than or equal to 1, we'll say inside plus equal to 1. Side plus equal to 1. Now let's print inside. Cell comma length of A. So see, of there are 785 roughly 785,000 points inside the circle. When compared, there are 1 million points. So here we have pi by 4 by 1. So this is the area of the quarter of the circle, and the area of the square is equal to area is nothing but the total number of points inside the enclosed enclosed area, right? So we here by calculating we saw there are 7 8 by 2 7 8, roughly say 7 8 7 8 5 3 by this total number of points that would occur 1 million. This is the ratio that we. So to find the value of pi, we'll get pi equal to 4 times this ratio thing, right? So, like let's say equal to 4 times of the value inside divided by total number of points. We can say total number of points is like length of A or B, same point. One is x coordinate and y is y coordinate. Let's print pi. See, the value of pi is giving us 3.145. So the original value is n power 5. Let's see. The original value is 3.1415. We almost got like roughly 3.1. To get a more precise value, we can increase the number of points that we are totally plotting. Let's say we are plotting some 10 million. First, let's see some 10 million. So the same square, we'll get all the points will inside. Since it's plotting a lot of some. Let's I'll stop it for now. Let's calculate the same. It's going through each and every point, calculate distance. If the distance from origin less than 1 is adding number 1 side line. So each and every time you can count on right? So here you can see these many points are inside and these are the total points. Previously we got this is the value, right? Previous. Now we see it is slowly getting closer to the original value, 3.1415. So as we keep increasing the number of points that we are trying to plot using to do iteration, we'll get more pieces and more get a bit more precision inside. Hopefully you understood the Python language and how do we use things, how to print and how to handle if conditions and different methods available. So one small announcement is that we'll be sharing Excel sheet so that we can provide you the project that you are supposed to do. So this project will be mainly in Shiva. As we saw in the first class, there are different domains like data analyst, data engineer, and in the project we'll be handling the different all the three tasks. We'll get familiarized with what does a data scientist, what does data analyst and data engineer in you put and that will provide you with the project so that you start. So by next class, I think we'll get started with the machine learning lectures. Now the previously the resource that I shared was this intro to computer Python programming. This is the main resource that were like our textbook that you can for all the things related to machine learning. The best professor to follow is Andrew Ng. You might have heard of Coursera, right? He is the creator of Coursera. So here you can see his ML lectures. You can go through this all the lectures. These are like small lectures that once you understand, you can go back and refer to them. I'll give you a like introduction to different algorithms. You'll find all the detail explanation in these lectures. There are roughly some 100 odd lectures, and each is like 5-10 minutes. You can slowly go through them one by one. It's not like you need to understand each and every single line that's being said. You just need to go through it once, and you'll get an understanding of like what are the different algorithms available. Once you want to implement some algorithm, then you can specifically search for that thing. Let's say, see here there are different linear regression. So is the Octave tutorial is not required. We are using Python, right? This Octave tutorial is not required for us. So yeah, you can go through linear regression. Then comes logistic regression and regularization. What is neural networks? And there are like what are different types of ML algorithms that are available for us. Support vector machines is another algorithm. See, each algorithm has a single section dedicated to it, and each concept is very clearly explained. Uh, so there are different clustering algorithms, dimensionality reduction, anomaly detection algorithms, recommender systems. Yeah, you can go through these lecture videos. It is rather compulsory that you want to go through them to just to get understanding, rather than reading some textbook and listening to me go through the same thing. You can go it by yourself, and I'll give you an overview. The second, let's see the next part is our introduction to pandas. Pandas is similar to Excel. Uh, uh, don't worry, I will be posting these sources. Okay. Pandas is a library that we can use to read Excel kind of format data into Python. So each and every column can be said as a pandas series. Name would be pandas series. Each column in our table. Let's see. So here we are creating data. This PD dot series is a list. This will be our column. It will print out. Here we will get a data frame. This is a pandas series. If it has more than yeah, has more than one column, we'll call it a data frame. If it has only one column, we'll call it a series. So here you can see there is only one column. So this is the index. You don't need to worry about the index. This is just saying serial number. You have only one column. This is a panda series. To get the values back, we can just say data dot values. It will give us the values back again as a list. So we can also create a thing called index. This is the same 0, 1, 2 kind of index. So here, since we haven't specified anything, it defaulted to 0, numbering the index. We can use a different, say we can use our own indexing method to put different values. Here by default, the index is a range that is provided by pandas. By just saying data of 1 is similar to indexing through list or array. We are getting 0.5. See, there we got 0.5. Yeah, this is the same thing that we saw. This is the same format that we follow to do slicing within array. Is series is not nothing but a numpy array, just specialized form of So now, if we want to specify the index, we'll give a CM list called the index, and it will, rather than creating 0 or 1, it will come like this. I think we can even give different indexes. So I guess we'll stop our class here. We'll then go through the same thing. We'll pick up the things from here. Yes, we have 5 more minutes for any questions.